All right, so in this video, we're looking at dividing with radicals, but more specifically, we're looking at dividing with our square roots. And so a lot of the problems we're going to be seeing, they're going to be in the form of fractions. So we'll have something like, let's do A over B, and it'll be a big square root over the entire fraction. Looks scary, super scary. All right, but it's not. There's a really helpful property that we can do is we could actually split that square root up over the top and the bottom. So we could have the square root of A on top for our numerator, and in the bottom, you can have the square root of the bottom number, whatever that's going to be, B. So it's a very helpful strategy. All right, so the next thing we're looking at for this, there's three things that we have to remember when dividing radicals. So using that property, we have to look to one thing to do is to simplify all the radicals in the problem, both the numerator and the denominator. The second thing we have to do in dividing these radicals that's to simplify, reduce the fraction, all right? And we're trying to reduce and simplify the fraction. We're going to use the same kind of concept we did with our multiplication, where we're looking to reduce the outside parts and the inside parts separate. So just like multiplication, keep the reducing separate. The last thing we have to remember to do in our dividing with radicals is try not to have any radicals left in the bottom of our fraction in the denominator. So through simplifying all the radicals and trying to reduce the fraction as much as we can, we're trying to leave a radical not in the bottom, trying to make sure we have no radicals left down there. But sometimes it does happen, and so we'll learn how to deal with that. It's called rationalizing. And that'll be something we'll learn in a later video. All right, so let's do some examples. All right, so in this first example, we have simplify the square root of 8 over 100. So if you can't see the root, make it a little bit darker. There we go. All right, so we can probably, if you're thinking right now, maybe we can reduce that fraction. A lot of you are probably thinking, oh yeah, we could divide each of these by 2 and to reduce it. But remember, we have that really cool property up here. Let me scroll up a little bit. Really cool property. Well, actually, kind of maybe it's more of a neat property, right? We could split the radical to the numerator and the denominator. So let's go ahead and do that down here. So we could rewrite this to have the square root of 8 over the square root of 100. So again, we just took that radical and we split it to both be on the numerator and the denominator. Now, why would that be very helpful? Do any of you see why? Hopefully you do see that there is a perfect square in either the top or the bottom. Where's that perfect square at? That's right, it's down here, right? The square root of 100. We could actually take the square root of 100. So we know that to be 10 on the outside. So let's go ahead and rewrite this fraction as we were simplifying it. So now we have the square root of 8 over 10. All right, so now look to simplify our fraction. And this is the next common mistake that happens is students want to try to simplify 8 over 10. But look closely. 1 is inside a radical, the numerator, 8, and the bottom 10 is no longer inside the radical, it's outside. So we can't simplify these numbers together, okay? But we can do is we can simplify root 8, right? We've broken that down before. So if we try to break down root 8, we would use the square root of 4 times the square root of 2. And we know the square root of 4 is 2. So that whole top numerator, root 8, gets rewritten as 2 root 2. Let's go ahead and do that down below. All right, so I'm going to go ahead and make an equal sign here. Root 8 is now written as 2 times the square root of 2, simplified. And that's still over 10. All right, so now Now we have numbers both on the outside, both on the top and the bottom, right? We have a 2 up top and a 10 down below outside of radicals. So we could simplify those numbers together. 2 over 10, what number can fit into both 2 and 10 to reduce them? That's right, 2. 2. You can divide each of these by 2. 2 goes into 2 once and goes into 10 5 times. Again, notice we only do the outside numbers, don't touch the inside number unless you have another part inside down here. All right, so just going to clean up our simplifying here to get our final answer. So we'd have 1 root 10, or not root 10, 1 root 2 over 5. And that's our final answer. And again, you don't need that 1 right there, so you could write it as just root 2. That's an ugly root. Hold on. The square root of 2, that's a lot better, over 5. All right, I'm going to go ahead and squeeze in one more example on this page. Let me kind of zoom in down here in this open space. I think that'll be enough room. All right, so here's another way you might see these division problems with radicals. You might see it actually written out for you, like divide this by this, or you might see it symbolized with our division symbol. Um, the best way to handle these is just rewrite it as a fraction. And don't forget, division symbol is actually the symbol of a fraction. Look at that. That's the numerator, or that's the fraction bar, and get the dot as a numerator over dot. That's a division symbol as a fraction. So go ahead and rewrite this as a fraction. The first part is on top, and the second part will go on the bottom. So there we go. There's our numerator over our denominator. So now we have 2 root 50 over 3 root 2. It looks a lot more like the problem above. So you can see right now you might want to simplify the square root of 50. But remember our property, if I zoom back out really quick, can I do that? Oh yeah, right? Our property up here where we could take the radical and split it up, we could also put it over one big radical, right? I could take these two radicals and put it over one huge radical and simplify the fraction on the inside that way. So let me go back and zoom into that. Because if I look at this, 50 over 2, the square root of 50 over 2, let me go ahead and separate that out here. The square root of 50 over 2, I could simplify 50 over 2, and that would be the square root of 25. A lot easier to deal with because we should know that's the square root. 25 is 5. That's a perfect square. So that whole part right here turns into 5 on top. 5 on top. What's still there, though, we do have to multiply. So that 2 is going to multiply with this 5 on top, right? So that'd be 10, 10 on top, and then 3 is by itself on the bottom. Just going to recap what happened there too, right? Because I don't want to lose anybody if I'm going from here to there. So what we still have in the fraction is 2 over 3, but what we happened when we did is we reduced this to be, whoops, this 50 over 2 became root 25, right? And that was now on top of the fraction. Go ahead and draw that there really quick. This was now on top of the fraction. It was 2 root 25. And then we would take the square root of that 25. We get 5. And that's where that 5 times 2 to get 10. And that's where the 3 stays at the bottom. All right, so here's our third example for our dividing with square roots. So now we're adding more stuff to the mix. So now we see that we do have a number on the outside and the bottom, okay, and we have root 40 over root 10. All right, so again, look to see what you can simplify, whether it's in a radical or as a fraction. So hopefully you recognize right now that we can take one single radical over this because if we remember, there's a 1 on the outside right here as well. 1 root 40 over 4 root 10. We could separate the outside and the inside. So that would equal 1 over 4, okay? And then we would have one big radical of 40 over 10. And that's helpful because we could reduce 40 over 10. That would become just 4. So this part right here would simplify to the square root of 4. So we would have 1 over 4 times the square roots of 4, and we should know the square root of 4 is a nice perfect square to get 2. We end up with 2. So now we multiply straight across our numerator, 1 times 2 to get 2. And then down the bottom, 4 times 1 to get 4, and then look to reduce that fraction, simplify that fraction, and then we can. What number are we going to use to reduce it? It's going to be 2, and what will that reduce to is 1 over 2, and that's our final answer for that example. All right, so on this next example, it looks crazy, but it's not too bad because we have to remember we are going to do our reducing with the outside and the inside separate. So I think it's a very helpful strategy to go ahead and separate out our two different parts, right? So we have to, we're going to have to do 8 over 2. So 8 over 2 times our square root of 24x to the 7th. Make that a little bit better. And that's going to be over our square root of 3x. All right. Because again, now we can use that property of one single square root. Okay. So we take that part over here, rewrite it as one single square root. So that would be the square root of 24x to the 7th over 3x, because now we could reduce this inside part. Okay, let me go ahead and move the page up a little bit. Whoops. Okay, so looking at this one, we're going to reduce 24 over 3. 24 over 3 would be the square root of 8 on top. So 8 over 1, just the square root of 8. So that would be the square root of 8. And now looking at x to the 7th over x, 7 minus 1 will leave 6 copies on top inside the square root. So that whole square root part here that we started with 24x to the 7th, root 3x, that all simplifies down to 8x to the 6th. Okay, that's the inside, but we're not done yet. All right, let's go ahead and clean up the outside part that we've separated out. So 8 over 2, this part will be 4. So go ahead and write that down here. 4. Oops. All right. And now that's going to be multiplying with this 8x to the 6th that we simplified with the square roots. So the square root of 8x to the 6th. But are we done with this problem? Right? Are we done by just doing those two parts? Good, right? We're not. We still have to simplify this square root. All right, so let's go ahead and break down this with the square root of 8, square root of x to the 6th. All right, now we're going to break down root 8 with 4 times 2. Square root of 4 becomes a 2 on the outside. All right, the square root of x to the 6th, that's a perfect square, or is it? Hopefully you said yes, right? Because that's an even power. We could square root that, and what happens is we get x to the 3rd on the outside. The last thing we're going to do now is multiply everything together on the outside, right? So we're going to have 2 times 4 times x to the 3rd. 2 times 4 is 8. And then we're going to have inside, oh, don't forget, at 8x to the third. And then what's still inside our radical is the square root of 2. And there is our final answer all that after all that work. All right, I'm going to go ahead and zoom in here at the bottom of the page to do our Padawan practice before we end our video. So I'm going to go ahead and make some room. All right, so here is your Padawan practice for this division concept with radicals. So go ahead and simplify this problem right here. 6 root 98 x to the fourth on top, all over the square root of 2x. Again, remember you're trying to simplify your radicals, your fraction, and also remember you cannot have a radical in the bottom of your answer. All right, so I hope you try the problem to the best of your ability, and I hope you get to an answer with no radical on the bottom. So remember, if we're trying to do that, always try to see if you can fit this bottom inside to the top up there, right? Because since they're both underneath a radical, right, you could put them over one whole big one and try to reduce that fraction, okay? Because that 2 will divide in nicely to 98. Okay, 98 divided by 2 is going to be 49. All right, so I'll still have the 6 on top, but what I have now is the square root of 49. All right, now same thing with my x's, my variables. X to the fourth over x, 4 minus 1 will leave me with one copy inside. I'm not one copy, I'm sorry, 3 copies inside. All right, so now there's nothing left in the bottom of our fraction, right? So I can go ahead and get rid of this denominator. All right, so next I have to do is simplify my radical, right? So the square root of 49, right? If you don't remember, hopefully you do, that's a perfect square. That's going to turn into 7 on the outside, 7 on the outside. But what we don't have a perfect square with is x to the third. So we have to break that down with our odd power procedure. So remember, we're going to subtract 1, okay? So split it up to the previous even power, because now you can take that previous even power and cut it in half. Rule of Thanos, right? Cut that thing in half, half of the x's survive, x to the 1. All right, so now on the outside, to finish our answer here, multiply 6 times 7. So 6 times 7 will give us 42. And still outside there, almost forgot, is x. So 42x on the outside. And still inside our radical is one copy of x. So there's our final answer, 42x root x. All right, may the math be with you.